So, dear students, let's talk about the equilibrium of forces. This we will get to know why not with the help of truss structure. Okay, so let us have a truss. This is the one triangle, this is the another triangle, and this is the third triangle. And suppose it is the name, we are naming it A, B, C, D, and E. And joints, as the truss is made of number of triangles. So there are three triangles, and the one triangle, this is the A. One triangle is made of three members, like this one, this one, this one. And how it is loaded? So truss is loaded at the joints, and how much force? So it is supposed 2 kilonewton, and here at the joint C 4 kilonewton. Okay, now suppose the ends A and D both are supported by the either roller support or the hinge. Suppose here roller support, roller support and here hinge or pinned support. Okay, so we need to remove the roller support, as we have to draw the FBD. FBD means the free body diagram of the structure. So for that we need to remove the support reactions. So here, if you remove the support, roller supports, so which the force which replaces the roller support is here. This is the vertical force, and here it will act at the joint A. The name RA. And here the hinge support which supplies two reactions, either the, here suppose the vertical reaction RD and RD, here we can write horizontal, this is vertical. Okay, so as we can see the structure, there is no horizontal forces acting on the system. The two forces only acting, 2 kilonewton and the 4 kilonewton, both are vertical forces. That's why there is no load to balance this horizontal reaction. That's why its value will be 0. Okay. So in this way, both the support reactions are replaced by two vertical reactions, Ra and Rd. We this we can write is equal to Rd for the more simplicity, because there is no vertical horizontal reaction. That's why Rd itself is vertical reaction. Now after this, so as we have the truss structure, labeling we can give 2D truss carrying loads, LO loads. Okay, our objective is find the axial forces in all members of the truss as shown in figure. Okay, so all the support reactions are replaced by two reaction forces, Ra and Rd. There are two active forces or you can say externally applied forces. These are 2 kilonewton at joint B, 4 kilonewton at joint C, and these two are known as reactive forces. Now, due to active forces, the forces are being distributed in the truss. The forces are being distributed among the members like AB, AE, BE. But how much forces are being distributed, that we need to analyze कि कितना डिस्ट्रीब्यूट हो रहा है. 2 किलो न्यूटन 4 किलो न्यूटन फोर्सेस जो लग रहा है ट्रस पे, वो कैसे डिस्ट्रीब्यूट हो रहा है और कितना शेयरिंग है फोर्सेस का, बाकी मेंबर्स का कैसे शेयरिंग है. सो दिस वी हैव टू गेट नाउ. सो फॉर दैट फर्स्ट what we have to get the support reactions values Ra and Rd we have. These are two unknowns, But how to get? So first approach is, here we are now applying equilibrium equilibrium of conditions, equilibrium conditions we are going to apply. So first one, summation of forces is equal to 0, and the second one, summation of moment about any point is equal to 0. Here, because it is 2D, so that's why summation of forces in y direction also is equal to 0. So we have three equations, this one, three equations. So applying the first one, because this one, summation of fy is equal to 0, because this is not uh, means this we cannot apply here because there are no horizontal forces. That's why summation of fy is equal to 0, and then what we will get, ra plus rb. So vertical forces we are taking positive directions, and the vertical upward forces ra, see the direction is upward, here also direction is upward, that's why positive values, and is equal to now 2 plus 4. These are acting downwards, that's why negative directions, and इक्वेटिंग करने पे आपका 2 plus 4 is equal to 6 kilo Newton. Okay, this is one equation. The second one, we can apply the moment equation, either moment about, suppose A is equal to 0. So moment about A is equal to 0 means the moment about A we are taking here. So RD multiplied, and the direction here we are taking negative, the clockwise negative. So one can see, if suppose the joint D, suppose a force RD is being applied here, and it will try to rotate this point, means there is a moment about A, so it will try to, this RD will try to rotate it anti-clockwise. So anti-clockwise we are taking positive. And what about the distance? So from here, the distance is given here in this equation, it is 3 meter, and angles are also given here, these are 60 degree. Here also these angles are given 60 degrees, this one and this one, means it is equilateral triangle. Okay, so RD, this distance we want to know, so this will be 3 plus 3. Now the 4 kilonewton force which is acting vertically downward, and how it will try to rotate, it will try to rotate the joint A the clockwise. So that's why clockwise minus, and the force 4 kilonewton multiplied by 3 plus 3 by 2 minus so this will be minus, then we have to consider this 2 kilonewton force, and it will try to rotate about means the clockwise rotation will be there, that's why with minus sign, and this is the force multiplied by the distance, this one from here to here, it is 3 by 2 is equal to 0. So by solving this we get RD is equal to 3.5 kilonewton. Okay, so from the first equation we can get if R, this is RD, actually this is RD, if RD is equal to 3.5, then obviously RA is equal to 6 minus 3.5 is equal to 2.5 kilonewton. In this way, now we have values of both the support directions. Now next we have to draw the FBD, free body diagram of the each joint, so that we can get the forces in each member. So now coming to joint A, here applying equation of equilibrium, equation of equilibrium. We get summation of fx is equal to 0 and the joint A, this is the joint A, this is your RA is equal to 2.5 kilonewton, and this is one force, this is another force, and the name, this is F BA, this is F A E. So what we have to do, directions we have to take the tensile, means the arrows are away from this joint. This angle is here 60 degree. So now applying the equilibrium of forces, summation of Fx is equal to 0. So the direction F A E with positive direction one can see, plus F A B or the B A B cos 60 degree is equal to 0. So from here F A E is equal to minus F A B cos 60 degree. So FAB we don't know, and this is equal to FBA. So better to write like FAB, FAE in this way. So now summation of Fy is equal to 0. Then what we are getting RA in positive direction plus FAB sine 60 degree is equal to 0, and RA already we know 2.5 it is. So from here FAB sine 60 degree is equal to minus 2.5. Then FAB will be, after solving this, minus 2.89 kilo Newton. Okay, so hence it is minus sign, there is minus sign, but we have taken FBA, the tensile, but actually it will be in compression, means like that. So here no need to correct whatever, here we can write it 2.89 kilo Newton, and in bracket we can write C, capital C, it means compressive. So either write the sign convention minus, or if you want to remove, then in bracket we need to write the compressive, C compressive. Okay, so in this way now FAB, if we put the value of FAB, if we put in this equation, so F A E we get what, and whenever you put with the same sign convention, like I am putting here minus FAB, so this is 2.89, then cos 60 degree. Okay, so always carry the whatever the sign, like minus sign here I have put with the same value, and the minus was already there. So what we get, that is in positive value, and that is equal to 1.44 kilonewton. So in this way we can get the all forces. Now for joint B, here one thing we are not applying the moment, means not applying the equation of equilibrium for moment, because all the joints you can see here, means sorry, all the forces are passing through the common joint. That's why the moment about A we cannot apply here, because all the forces then will be zero, means no meaning. Okay, so similarly, like a joint A, joint B we can get. So for joint B, what we have to do, this is the joint B, and this is the force 2 kilonewton. This is F BC, this is F AB, F A B, and this is F B E. Okay, so this is known, F A B is equal to minus 2.89. What about FBE? It is unknown. FBC unknown. So we have two unknowns. And how many equations we have? Obviously, two equations we have. Fx is equal to 0, Fy is equal to 0. Then obviously these two unknowns can be evaluated, can be found out. So what we get, so by applying this means equation we can get, no need to again detail, just like joint A have to follow the same pattern. And always remember, whenever you are going to draw the free body diagram for each joint, if forces are unknown, so take it initially the tensile, the forces in tensions, okay, and whatever, whether it is tensile or compression, so what we get at the last, that will tell, like FAB here, we are getting with minus sign, minus 2.89, means it is compressive, means whatever we had taken the tensile, so that need to be reversed. ठीक है, तो आपको कुछ नहीं करना है, आपको जैसे है वैसे लिखना है, उसी वैल्यू के साथ लिखना है, और जहाँ भी आप सब्स्टिट्यूट करेंगे उसी वैल्यू के साथ, उसी साइन कन्वेंशन के साथ आपको सब्स्टिट्यूट करना है, आपको चेंज कुछ नहीं करना है, जैसा जो वैल्यू आ रहा है जिस साइन के साथ वैसे ही आपको पुटअप करते जाना है। एंड एट द लास्ट आपको जितने भी फोर्सेस आ रहे हैं उसको एक टेबुलर फॉर्म में शो कर देना है, ठीक है, लाइक ये हो गया, तो दीज आर सपोज मेंबर ऑफ फोर्सेस एंड दीज आर द मैग्नीट्यूड and this is suppose nature, and this is magnitude, this is members, ठीक है। So nature means the tensile, compressive, okay, thank you.